Hello everyone, I'm Sebastian Y and this is Managerial Economics. In this video I'm going to talk about the Bertrand model of oligopoly. The Bertrand model is the other main oligopoly model alongside the Cournot model. It was developed by another French mathematician, Joseph Bertrand, in the 1880s. Bertrand came up with his model as a direct response to Cournot, which he thought was unrealistic. He felt it made more sense for firms to choose prices instead of quantities, and that is the main distinction between the two models. Initially, it may not seem like that would make a huge difference, but in fact it does. We are going to focus on a duopoly again to illustrate the Bertrand model. Suppose we have two firms, firm 1 and firm 2, which produce identical products. In this model, the firms will simultaneously choose prices, P1 for firm 1 and P2 for firm 2. Already, this is a major difference from the Cournot model. In the Cournot model, there is only one market price that is determined after the firms simultaneously choose quantities. From there, we have a demand function, Q of P. In the end, the firms are going to be producing Q1 for firm 1 and Q2 for firm 2. These two quantities are determined once the two prices are chosen using a specific set of rules. Since the products are identical, consumers are always going to buy from whichever firm charges the lower price. If it's a tie, then they will split equally. Let's write this down mathematically. So if we have P1 less than P2, that means that firm 1 was able to undercut firm 2 and take the entire market. That means Q1 is going to be Q of P1. They'll take the entire market, however much quantity is demanded at that lower price of P1. Since firm 2 got undercut, they're going to sell nothing. If P1 is greater than P2, then the opposite happens. Firm 1 sells nothing, but firm 2 sells whatever quantity is demanded at that lower price of P2. In the final case, we have P1 equals P2, which we will set equal to a generic price that is the price both of them charge. If this is the case, the two firms will split the market equally, and that will be a quantity of Q of P divided by 2. Let's look at what happens in our example. Suppose we have our two firms' cost functions, C1 of Q1 equals 40 Q1, and C2 of Q2 equals 40 Q2. This means that the marginal cost for firm 1 is 40, and the marginal cost for firm 2 is also 40. Our demand function is Q of P equals 320 minus 2P. I want to point out here that the Bertrand model is all about choosing prices. And so we are going to work with the regular demand function, Q as a function of P, as opposed to the inverse demand function. So if you start out with an inverse demand function, you are going to have to flip this around and make sure you get the regular demand function. Let's think about what firm 1's best response function might look like. Let's think about what the best responses would be for each firm, starting with firm 1. We're going to take firm 2's price, so P2, as a given, and consider what firm 1's best response to that would be. So for example, let's suppose that P2 is 60. With this in mind, we know that if P1 is greater than 60, then firm 1 is not going to sell anything. The customers are going to all go to firm 2, and so that's going to leave us with 0 profit. Now, what would happen if firm 1 were to price slightly under 60? This means firm 1 is going to take the entire market. The final choice would be for firm 1 to price exactly at 60. In this case, they would split the market in half with firm 2. So what's the best response here? Clearly, pricing above 60 would not be the best choice. Pricing exactly at 60, they split the market, but if they priced slightly under 60, the tiniest amount under 60, they would take the entire market, and that would be the most profitable option. So could that be a Nash equilibrium? Firm 2 prices at 60, firm 1 prices slightly under. This cannot be a Nash equilibrium because firm 2 would not be best responding. At this point, firm 2 would want to price slightly under firm 1, and then take the entire market. But that's not a Nash equilibrium because firm 1 would then go slightly under that. This means that the only place we could have a Nash equilibrium is for both firms to be unable to profit by undercutting each other. And that happens when both firms are pricing at marginal cost. And remember, our marginal cost for both firms is 40. And so if P1 is 40 and P2 is 40, I'll use a superscript Bert to denote the Bertrond equilibrium. Our equilibrium quantity will be 320 minus 2 times 40, which is 240. And that means each individual firm is going to sell 120 units. And the profit they make is going to be 120 times 40 minus 120 times 40. They're charging a price exactly equal to their average cost, and so they're going to make zero profit. Now the question is, could either of these firms improve their profit by changing their price? So for example, if firm 1 were to slightly increase their price, could they make more profit? And the answer is no, because if they go above 40, they're not going to sell anything, and they're still going to make zero profit, so no improvement. Now if firm 1 were to price slightly under 40, they would take the entire market, but they're now pricing under marginal cost, and they're going to get a negative profit. And so neither firm can improve by switching, which means that this is a Nash equilibrium. This is a very interesting result because all it takes in the Bertrand model is to get two firms to drop the profit all the way down to zero. The competition here in Bertrand is much fiercer than in Cournot. In Cournot, the firms still did okay. They didn't make as much profit as in Monopoly, but they still made a decent profit. And that's because in Cournot, you can't actually undercut the other firm. The only thing you can do is produce more or less output. This also means that the Bertrand model is socially efficient, because price equals marginal cost. That is certainly not the case in Cournot. The last thing I want to talk about here is how firms might collude in the Bertrand model. Remember that if firms collude, they are maximizing their total profit collectively. And in order to do that, they act like a monopoly. And so in collusion, the price that we want to charge is the monopoly price. So that's going to mean P1 equals P2, which is PM, the monopoly price. In our example, we solved for this in the previous video and found that the monopoly price was 100. Following the rules of the model, then they will both split the market in half and then therefore make half of the monopoly profit, which in the previous video we showed was 7,200, the monopoly profit, divided by 2, 3,600. Comparing this with the Bertrand competitive equilibrium profit, this is far better. Compared to Cournot, it's an even bigger improvement. However, the temptation to cheat on the collusive agreement is very, very high in Bertrand, because all they would need to do is price slightly under 100 and then nearly double their profit. And for this reason, collusion is going to be unlikely to hold up in the one-shot setting. Once we take this to a repeated interaction, though, it might be possible. In the next video, we are going to wrap up our discussion of oligopolies by looking at what happens when the firms no longer have equal marginal costs.